Hello, we'll have now a theorem about independence, which is if two random variables x and y are independent, if x is independent of y, and then we have a function of g of x, and then I have another function of h of y. We want to show that these two guys are also independent, provided that the inputs are independent. So theorem is that for any two independent random variable x and y, then a function of only x and a function of only y are also independent. Let's prove it. So let us denote a of z by this event and b of w by this. In that case, the joint CDF is a probability of az and bw. Or in other words, we have this event. So in other words, in order to calculate this one, we have to integrate from the joint CDF over the range of possible values where x of c is inside az and y of c is inside bw. So because they are independent, this function is decomposed to f x of x times f y of y, because we assumed independence. Because of this one, we can substitute this function. As soon as you substitute this function, you can decompose these two integrals. So obviously, this is probability of the first event, and this is the probability of the second event. So this becomes fz of z and fw of w. Therefore, you could say that this is valid for a pair of z and w, and this is valid for all z and for all w. Therefore, they are independent, and the proof is complete.